Hey everybody, it's Mr. Carr again. Today we're going to be starting up 8.3. This is going to go over 3 days, and we're going to be looking at what's called trigonometry. Okay, today we're going to be setting up what's called trigonometric ratios. Okay, um, so yeah, that's our goal for today is just setting things up. When we look at trigonometry, that is the study of the relationship between sides and angles of triangles. So this is a whole subset of math that focuses just on triangles. Okay, so that's what our focus is here is trigonometry. So super fun, all triangles all day long. It'd be a good life and good job, huh? Okay, so when we talk about this, we're going to introduce a couple of terms that we need to cover, and those are just going to be the idea of opposite sides and adjacent sides. I'm going to start with adjacent. Adjacent, I like to think of as being attached to an angle. Okay. Opposite is going to be what is the other side. It's on the other side from that angle. Okay. And when you see that, you're going to look at something like this. So if I look at, for example, let's say I reference angle D here. Angle D, when I look across from that, so when I look all the way over here, that is my opposite side. When I look at this side, that's adjacent. Okay, it's attached to D like this. Now, don't confuse it with the other one because that one is still actually our names from before. It's across the 90 degrees. This is my hypotenuse. Okay, so when I look at an angle like angle D, I can label all three sides of the triangle as adjacent, adjacent, opposite, and hypotenuse. Okay, now if I change my reference, if I look at, let's say, angle M here, well, when I go across, I go to the other side, this is my now opposite side. You notice how it's not the adjacent side anymore. Whereas this side right here, that one's adjacent because this is the one that's attached to M. The hypotenuse is still the hypotenuse. I do not change that name. It always stays like that. Okay, so that's what we're looking at here. So in trigonometry, we're going to set up certain ratios. These ratios depend on which angle you're referencing. And we're going to look at this as Sohcahtoa. That's a nice quick way to remember certain things with this. Okay, so means that sine is going to be the opposite over the hypotenuse. That's where the so comes from. So S-O-H, sine opposite hypotenuse. That's the ratio we would set up. So for example, for sine of D, I'm going to look here at angle D and see what side is opposite. It's MB here. So this is going to be MB divided by the hypotenuse, which is MD. Okay, and again, like I said, hypotenuse is always the same thing, no matter what. Okay, if I do the sine of M, M is right here, but now my opposite side is over here. It's BD. Okay, so that's going to be BD, but still over the same hypotenuse of MD. Okay, again, hypotenuse does not change, but what's opposite sides depends on what my reference angle is. I move on to cosine. Cosine is going to be adjacent over hypotenuse. That's what the CAH is for. Cosine, adjacent, hypotenuse. And that's the ratio. It's adjacent side divided by the hypotenuse. So if I look at this here, again, cosine of D. D is right here. Adjacent is BD. Okay, this is the one that's adjacent there. So I'm going to put BD up here. And it's over the hypotenuse, so it's still MD. When I reference M, the adjacent side is this one. It's MB. Okay, so that means that MB will go here, whoops, over MD for my hypotenuse. The last thing is what's called tangent. Tangent, TOA. So tangent, okay, the tangent is going to be opposite over adjacent. And so when I look at that here, again, in reference to D, opposite side is over here, MB. So that will be my numerator. The adjacent side is this one. It's BD. But when I reference angle M, opposite is over here as BD, adjacent is MB. So BD and MB. Take a look at this a second. There's actually a few patterns we can kind of analyze. Okay, one of the things I like to look at is the fact that if I look at the sine of one angle, that's the same as the cosine of the other angle in that triangle. Okay, look at how those match up. BD and MD are matching up. MB and MD also match up. So the sine of one angle and then the cosine of the other angle are actually the same. The other pattern I would look at is if you look at the tangents of these two. This and this are reciprocals. So the tangent of one angle is the reciprocal, the same as the reciprocal as the other one. Okay, so that's what we're looking at there. Just some quick little patterns. But this is how I'm actually going to use this. So we're going to find the sine of U and the sine, of W. So just like I said before, and this is the process I like to work with on this. If I start with U, I'll do that in blue actually. I look at U as my reference. I'm going to label it real quick as opposite, adjacent, hypotenuse. So we have opposite, adjacent, hypotenuse. If I look back at what I'm doing, sine, so the SOH, so I'm going to do sine as opposite over hypotenuse. So in the case of U, that is going to be 16 over 34. It says here to write each answer as a decimal rounded to the nearest hundredths. So I'm going to go ahead and just plug that in my calculator, find out what the sine of U is equal to. So sine of U is equal to 16 divided by 34. And that's going to give me 0.47 hundredths. So that's going to be 0.47. That's it. But now when I do W, W as a reference, if I look at sine, opposite W is this one, adjacent is this one, this is still the hypotenuse. That did not change. So sine of W is going to be opposite, which is 30 over 34. So sine W will equal to 30 divided by 34, which gives me 0.88. Okay? No, it doesn't. Hold on a second. Oh, no, we're good. This is for something different later. Okay? So that's where we're getting these answers. Like, that's where we're setting these up. These are the ratios here, and it simplifies into like decimals like that. Now, if I wanted to, like I could ask you to go ahead and simplify the fractions and like leave them in fraction form. So for example, divide by 2, that's going to be 15 over 17. Okay. The other one, if I divide by 2, that's going to give me 8 over 17. Okay. You can leave them in that fraction form or the decimal form. It just depends on what the problem's asking for. So in this case, I wanted hundredths, so that's where those come from. And that's it for setting up. Okay, that's all we're practicing today. So when I'm going to do cosine, I'm going to do the same thing as before, but now because it's cosine, remember what that means. Cosine, if I come back up here, was CAH. So it's adjacent over hypotenuse. Okay, so as a reminder, sine is equal to opposite over hypotenuse. Cosine is adjacent over hypotenuse. Okay, so again, if I do cosine S and cosine R. Okay, so for my reference for S, this is opposite, this is adjacent, that's hypotenuse. So opposite, I'd be saying this a lot today. Cosine, I'm doing adjacent, so I need an adjacent side, which is 45. Hypotenuse is 53. Okay, and then R, if I use that as a reference, this is going to be opposite over here. That'll be adjacent. Hypotenuse is still the same. So in this case, my adjacent is 28, and hypotenuse is still 53. And just like before, I'm going to go ahead and divide these out. So I got 45 divided by 53. So that's going to give me cosine S is equal to 0.85. I'm going to round that off to 85. And then I do the same thing with 28 divided by 53. And that's going to be 0.53. So cosine R is equal to 0.53. All right. Last one we'll cover today, and that is going to be the tangent ratios. Okay. So tangent ratio, tangent, if you remember, is going to be equal to the opposite side divided by the adjacent side. So I'm going to do tan S and tangent R. I just ran out of space by myself. Let me try that again. Okay, so the tangent of S and the tangent of R. Okay, so if I do blue for tangent S, if that's my reference, opposite side is over here, adjacent side is right there, hypotenuse is right here. Okay, I'm going to do opposite divided by adjacent, so that is 60 divided by 25. For the other case, I've got my references R, my opposite is over here, my adjacent's here, my hypotenuse is there. Okay, I think this is a really good strategy where you every time you look at a reference angle, label opposite, adjacent, hypotenuse. If you need to label it twice because you're doing two different angles, that's fine. But just be aware of what's going on there is the key. So if I look at opposite, that's 25 over 60. Okay, so now I can go ahead and calculate this out and round them off to the hundredths. So I got 60 divided by 25, which is going to give me 2.4. So tangent of S equals 2.4. And then 25 divided by 60 is going to give me tangent, let me change that to red. Tangent of R is equal to 0.42. Okay, and like I said, that's it. We're going to be taking this trigonometry and taking it a little bit further in the next couple lessons. But for today, that's it. That's all I want you to do is set them up. Okay, set up the fractions and then turn them into decimals because that's what we're asking for here. So I'm going to let you do these two you try not problems. Okay, give them a shot. If you need help on that, let me know and I can help you out either during office hours or any of the homework and things like that. Okay. All right, that is it for today. I will talk to you later. Have a good one.